This video will review simplifying radicals. And this is a skill that's needed in Algebra 1 when you're working with quadratics, and it's a skill in and of itself. But simplifying roots with the quadratic formula, you don't always have a perfect square underneath the radical, so this is a little skill that you need to have in order to simplify a quadratic root in reduced radical form. So you need to know how to work with roots, square roots that are not perfect squares. So number one, you're always looking for the largest perfect square factor. Well, 125 is 25 times 5n, and we'll deal with the variables in a minute. So I can think of this as the square root of 25 times the square root of 5n. 25 is the perfect square, so square root of 25 would be written as 5, but the radical 5n would have to remain as radical 5n. So this would be your simplified answer for number one. Number three, is 256, which is a perfect square, 16 times 16, times 2k squared. Just a word about variables under the radical. If the power on the variable is even, you can think of this as, I'll just make a little example. This would be k cubed times k cubed. So anytime you have a number times itself, it's a perfect square. So the square root of k to the sixth power would be k to the third outside of the radical. So when the power is even, you simply divide it in half, and the square root of this would be k to the fifth. Do another one. If I have the square root of k to the 20th, 20 divided by 2 is 10, so the square root of k to the 20th power is k to the 10th outside of the radical. So when the exponent or the power on the variable is even, you simply divide it in half, and then half the power becomes the square root. So that's what you would bring out whenever you simplify to write the square root of a variable. When the variable is not even, so if I have k to the 11th, just subtract 1 to get to the even power. So k to the 11th, using properties of exponents, is k to the 10th times k to the first. Well, the perfect square here would be k to the 10th because 10 is an even number. So this would be k to the 10th times k to the first. K to the 10th is k to the fifth outside of the radical. The k to the first remains inside the radical. If I had the square root of k to the power of 31, we'll try that. If I have k to the power of 31, if I subtract 1 from 31, that gives me k to the 30th times k to the first. The perfect square is k to the 30th because 30 is an even number. 30 divided by 2 is 15. So the square root of k to the 30th is k to the 15th outside of the radical, and then k to the first remaining underneath the radical. So now let's go back to the handout and practice a few of these together with numbers to get you more comfortable with this. Number three is 256, which is a perfect square, times k squared, which is a perfect square because the power of 2 is an even number, times 2. So that's the square root of 256 times the square root of k squared times 2. And taking each of these individually, the square root of 256 is 16, the square root of k squared is k, and then the radical must remain with the 2 underneath it. So that would be my simplified answer for number 3. Number 5, 216k to the 4th. 216 is 36. 36 is the largest perfect square factor. K to the 4th is a perfect square. And then a factor of 6, which is not a perfect square. So if you write your, along the way to simplifying, if you present your answer the way I've done it on the video, then it's really easy to figure out what your perfect squares are. The square root of 36 is 6. The square root of k to the fourth, divide 4 by 2, so the square root of k to the fourth is k squared. The only non-perfect square is 6, so that becomes your simplified answer. Let's look at number 8. Number 8, 9 is the perfect square factor. P squared is a perfect square because 2 is an even number, and then you have the factor of 5. So if you write all of your perfect squares out the way I have, you don't have to do it this way, but it does make it simple to figure out what your simplified answer is. The square root of 9 is 3. The square root of p squared is p to the first, and then 5, not a perfect square, must remain under the radical symbol. Let's do number 10. The perfect square factor of 200, the largest perfect square factor is 100. M to the fourth is a perfect square. And I have a numerical factor of 2, and then I have n to the first, not a perfect square. So the square root of 100 is 10. The square root of m to the fourth is m squared. And then remaining underneath the radical would be the factor of 2, and then n to the first power. Let's look at number 11. 25 is the largest perfect square factor of 75. X squared is a perfect square, and I have a factor of 3 as well as a factor of y to the first. Square root of 25 is 5. The square root of x squared is x, and then remaining under the radical, the 3 and the y, because they are not perfect squares. So hopefully that is enough of an explanation to get you through the problems. Let's just look at number 13 quickly. 16 is a perfect square. U to the fourth is a perfect square. The only problem is v cubed. So the square root of 16 is 4. The square root of u to the fourth is u squared, leaving you with v cubed. And the way you would deal with that, you would think of this as 4u squared, and you would have v squared times v to the first. V squared, because that's the even power of v, is a perfect square, so the square root of v to the second would be v to the first if you just simply take the 2 and divide it by 2. So your simplified answer here would be 4u squared with v to the first outside, but then v to the first has to remain under the radical as well, so that would be your simplified answer for that. Number 14, you have 4 times x squared times y squared, leaving you with a factor of 7, x, and y. I've just simply separated all of the perfect squares. So the square root of 4 is 2, the square root of x squared is x to the first, the square root of y squared is y to the first, and then remaining under the radical, the 7, the x, and the y. So that would be your simplified answer for that.